Okay. Anyway, we were introduced to our inverse trig. And inverse trig, we first of all learned that our inverse trig functions are restricted because we wanted to make them functions. And so they have a restricted domain and range, and that's going to definitely come more into our conversation today. But as we were considering our answers, we thought about where they were restricted. Inverse cosine is restricted to quadrants 1 and 2. Because this is a positive question, we know our answer will be coming from quadrant 1. This is where I went to my method. If I am a first quadrant person, I would have a picture of quadrant 1 and find the place where cosine had a value of square root of 3 over 2. If I'm a right triangles person, I would draw myself those two models and find the picture and the angle that gave me a cosine value of square root of 3 over 2. And if I'm a hand trick person, I would give myself 3 cosine fingers. So to do that, my reference angle would be here. There's cosine of square root of 3 over 2. And so the angle from quadrant 1 we should have picked would be pi over 6. Inverse tangent of 1, this is the one that always kind of throws us when we're thinking backwards because we see zeros and ones and want them all to be on an axis. But tangent has a value of 1, not on an axis. So if I go through my options for tangent, we've got square root of 3 over 1, square root of 2 over square root of 2. Or think about any of your other methods. The reference angle that gives me a tangent value of 1 would be pi over 4. And I forgot to talk through the beginning part of that, defined in quadrants 1 and 4, positive. So we're talking quadrant 1. And then inverse tangent of negative square root of 3. So again, defined in quadrants 1 and 4 because we're talking a negative. This time my answer is going to come from quadrant 4. To put me into quadrant 4, it's going to be negative. And again, if I go through my options for tangent, remember on tangent, they all look simplified. So I think about what is the unsimplified version of that. The one that would simplify down to the square root of 3 would have been a reference angle of pi over 3. Negative pi over 3 to put us in quadrant 4 where tangent is negative. Questions on any of those? So kind of getting our brain back into the thinking of inverse trig because that's what we're picking up today. At the end of our last set of notes, I left you off with, okay, we actually can do the inverse tangent of 4, not the inverse cosine and the inverse sine of 4 because of their restrictions, but we can do the inverse tangent of 4, and how are we going to do that? So we're going to look at some more unique ones today, some composite functions today where we've got a inverse inside of a normal inside of an inverse, all of that layered on top of each other. So we're going to start talking about composition of functions to start today. So reminding you of inverse functions and their compositions. We were introduced to the fact that if we do the inverse function of the original function, that they undo each other, and we just got x, right? And the other way around, if I were to do f of f inverse, they undid each other and we got x as our answer. And although that is kind of true for our inverse trig functions, you have to be very careful because of the restriction on our domain and ranges. So looking at these very carefully, if we did the sine of the inverse sine of x, you will get x for everything that is on the interval from -1 to 1. If we go the other way around, the inverse sine of the sine of x, you will get x as long as x is on the interval from -pi/2 to pi/2. So if we start out with something that falls in that pi/2 to -pi/2 to pi/2, we will just get that back out as an answer. But if this original x did not fall in that, our answer will be in that, and so it will be a coterminal to that or a similar answer to that, but not the same. So it won't always be straightforward, like directly undoing each other, and we have to pay attention to would that be in our domain for and our range for those functions. So looking at some examples here. Now, I will tell you that you can always fall back on just doing this as a 2-layer problem. What do I mean by that? When we look at these, I will always encourage you to just consider what the inside is as a separate problem and save the outside for just a minute. So if I save the outside problem for just a minute, sine of pi over 4 is just a unit circle question, right? Sine of pi over 4, we would have started by giving ourselves a little room here, drawing ourselves an angle of pi over 4 and thinking through our all students take calc. Okay, well, it falls into quadrant 1. My answer is going to be positive. I use my reference angle, pi over 4, do my method. Look at quadrant 1, look at my special right triangle, go to my hand trick. Sine would be the square root of 2 over 2. Positive because we are in quadrant 1. And so what I do is I just consider the inside problem. Once I've found that answer, now I move to the outside problem. Well, the outside problem is an inverse trig question. And so we attack it slightly differently. And I say, okay, where is inverse sine defined? It's defined in quadrants 1 and 4. This is a positive question, so my answer is going to come from quadrant 1. And then I go to my method and I say, okay, which one gives me an answer of square root of 2 over 2? So I need 2 sine fingers, or I look at my first quadrant, or I look at my special right triangles, and I come up with an answer of pi over 4. Now, that was an incredibly drawn out way of going about this. Look at the beginning and look at the end, and you might be thinking, can I just say that it's the number inside, right? Yes, if it happened to have been in that range of negative pi over 2 to pi over 2. So if the number we see here would fall between negative pi over 2 to pi over 2, like on the number line or on the unit circle, then yes, absolutely, it is the number that is inside of there, okay? And if you recognize that, you can skip all that work and jump to your answer. Otherwise, you can go through this work every time and it will always lead you to the correct answer. Questions? There's like one little case in your book that we will have to look at where we kind of have to just recognize that it will work. I'll show you an example like that here in a couple slides. So here's an example where it is not as straightforward. Is 5 pi over 4 in the range of negative pi over 2 to pi over 2? No, it is not. And so what happens is it does not directly undo each other because inverse sine can't have an answer of 5 pi over 4. It can only have answers from negative pi over 2 to pi over 2. So we have to go through that step by step that we just did on the last page. So again, I consider that inside function first and say, okay, 5 pi over 4. Again, go back to how did I do my unit circle, right? 5 pi over 4 put me into quadrant 3, where my answer appears to be negative, right? We're doing a sign problem in quadrant 3, sign's negative. So I go to my reference angle, pi over 4, which we just did on the last page. Sine of pi over 4 is square root of 2 over 2, negative because we are in quadrant 3. And then I shift back to what we did on Friday. Inverse sine of negative, square root of 2 over 2. Inverse sine is defined in quadrants 1 and 4. Because this is a negative problem, my answer is going to come from quadrant 4. The angle that gives me an answer of square root of 2 over 2 is pi over 4. To put me into quadrant 4, we put a negative on it, negative pi over 4. So there's an example of because 5 pi over 4 is not in the range from negative pi over 2 to pi over 2, it is not a straightforward undoing of each, that's not my answer. It's a similar answer, but not the same. Questions? Yes, if it's on our unit circle, because we're going to see some today that are not from our unit circle. But yeah, absolutely. The only time I'm going to hesitate is cosine. Cosine is because cosine is weird, right? So you might have to consider what it is in quadrant 2 instead of just the reference angle. But yeah, your reference angle should be identical. All right. So when is it possible to do this and when is it not? You do have to pay attention to, so look what I flipped it. Sorry, let's back up real quick. Do you recognize that all the problems we did so far had the inverse on the outside? So what if I move the inverse function to the inside of the composition? Not always possible, okay? So remember, to do this, you can only do a composite with the inverse on the inside if the number that is in here is within their domain, and their domain is -1 to 1. So for example, if I asked you to do the sine of the inverse sine of 2, well, 2 is not in that domain. This does not exist, right? And it's all the inverse and the fact that that has to be between -1 and 1. Okay, so we do have to slow down just a little bit. We'll talk about that later on. Again, if I don't necessarily have to recognize that because of the technique I give you later. We'll have a way to kind of have a kind of second check and balance there to make sure that you recognize that that still would not exist. And I'll explain why here in just a minute. However, remember that inverse tangent, it has an unrestricted domain, so it will always work. So for whether you're doing the inverse tangent on the inside or outside, it always works. You never have to remember the restriction on the domain on that one, okay? When can we do the other way around where the inverse is on the outside? Always, okay? So there's just that one little situation for inverse sine and inverse cosine that we have to be cautious of. But if your composition is this direction where the inverse is on the outside, it will always work because this first question will give us some sort of a value that we can take the inverse of, always, okay? All right. I want you guys to try this one on your own. Slow down and think about, do the inside problem, move to the outside problem. Okay, the challenge, especially as we start getting into today's material, is slowing down and recognizing, am I doing an inverse problem or am I doing a unit circle question, or like rewind a long time ago, gateway style questions, and the subtle difference in how we start them and what our answers look like, right? Because they are all so related and so overlapping, it gets confusing and people get confused in the middle of the process. So slow down and look at which one you're doing and how do we attack that one. On this first one, our inside problem, so I'm only looking at the inside right now, is an inverse. And inverse ones are the ones where we look at where is it defined. Defined in quadrants 1 and 2. I'm gonna stop there for just a second. Are we all okay with that? Okay, and when it's the inverse one, the first thing I want you to do is draw that little picture for yourself. What 2 quadrants can my answers come from? Okay. This is a negative problem. So this is the one on cosine you have to be cautious of. My answer should come from quadrant 2. So your options are like 2 pi over 3, 3 pi over 4, 5 pi over 6, right? And we got to figure out which one that is. Go to your method, whether you're looking at quadrant 1 or you are looking at your special right triangles or you are looking at your hand trick. Cosine having 1 finger would be a reference angle of pi over 3. But the pi over 3 that puts us into quadrant 2, where cosine is negative, is 2 pi over 3, always one less in your denominator. So this inside part has an answer of 2 pi over 3. And then we move to the outside question. And the outside question is, what is the cosine of 2 pi over 3? And the cosine of 2 pi over 3, that is where we go, okay, 2 pi over 3 looks like this. I think through my all students take calc. Cosine is negative in quadrant 2, therefore my answer is negative. My reference angle is pi over 3. Go to my method. A reference angle of pi over 3 for cosine is negative 1/2. And again, it absolutely can repeat our answer, and that is okay. It doesn't always, which is why we have to be a little bit cautious of kind of thinking through the whole problem. Questions? Okay, let's do one the other direction. Inverse sine of cosine of pi. Are you a hand trick person, a special right triangles person, or what? Hand trick, okay. So back when we did unit circle, I would have drawn an angle of 2 pi over 3, which would have put me here. Thought through my all students take calc. Cosine is negative in quadrant 2. I would have a reference angle of pi over 3. Cosine is my top fingers. Like how to draw a 2 pi over 3 angle? 3 over 3 and 6 over 3. So 2 over 3 is just short of 3 over 3. Does that help remind you?
Not really, but I'll just.
So like you have here 6 pi over 6 and 12 pi over 6 is always the denominator over itself for 1 pi. Double the denominator for a whole circle.
Okay. Yeah. And then how do we get?
Your reference angle is pi over 3. Cosine is your top fingers. Square root of fingers over 2. All right. So inside is a normal gateway unit circle question. So the first thing I do is draw that picture for myself. Well, an angle of pi puts me on that negative x-axis where we have an ordered pair of negative 1, 0. Cosine is our first value in each of those ordered pairs. So our answer for the inside question would be negative 1. And now we move to inverse trig thought process. And for a axis problem, I'm going to talk through all of our options here. Remember that sine hits 3 different places on an axis being defined in quadrants 1 and 4. In each of those ordered pairs, I would consider the second number because we are talking a sine question. So our second number in each of those would be 0, 1, 1, 0, and 0, negative 1. And we're looking for the one that had an answer of negative 1. Sine has a value of negative 1 down here. And in our inverse trig, we think of that as negative, an angle of negative pi over 2. So our answer to the inverse sine of negative 1 would be negative pi over 2. Questions? Okay. This one right here, I don't necessarily love this question. However, I do want to show it to you one time just so that if you run across this like on your My Math Lab assignment for this, that you'll be able to do this. I can't tell you what that is. I don't know what 0.7 is on the unit circle. It's not on my hand trick. It's not on a special right triangle, but is 0.7, does it fall on the range of inverse cosine, or sorry, on the domain of inverse cosine? It does. I can plug that in. And is it in the range of our inverse cosine? It is. And so what's happening on this, if this falls in our domain, we can do that. And then we would undo that with the cosine and we would just get 0.7. You just have to be careful that it actually works for both of those values. And especially this direction, we don't have to be as cautious because you don't have those domain and range restrictions on cosine. But we do on inverse. So if it had been flipped, we'd hesitate even more on that. Just make sure it works for that problem, okay? So look at this one. Can I do the inverse cosine of negative 1.2? Or yeah, negative 1.2. No, the only numbers that I can put into an inverse cosine are from negative 1 to 1. Does negative 1.2 fall in that domain? No, it does not. And so this does not exist. Every time you do an inverse cosine or sine, slow down. Is that even a possibility? Okay. Okay. We know that inverse tangent does not have domain restrictions. These are not the same function, so it's not just going to undo each other and get 5/12, right? So how the heck do I proceed from here? Well, this is where we are going to utilize the fact that we are building this by right triangles, right? I know that this works, and this, remember, is the value we get for some angle. And so if I look at this, what I'm going to do is build myself a triangle. I'm going to mark one of the angles. I always mark them as theta. It doesn't matter which angle you pick. But then we have to think through our SOHCAHTOA. Okay, right now we're looking at tangent, and tangent is opposite over adjacent, which means this is our opposite side, and this is our adjacent side. And what I can do is come down to my triangle and just mark it that way. My opposite side is 5. My adjacent side is 12. Inverse tangent would tell me what theta is for that. But eventually we want the cosine of theta. Well, cosine of theta requires adjacent and hypotenuse. Do I have the hypotenuse right now? Can I get the hypotenuse? Yes. What do we utilize here? Pythagorean theorem. You got it. Okay, so use Pythagorean theorem to find missing side. So in this case, that would be 5 squared plus 12 squared. Be good Pythagorean theorem people here. This also happens to be one of your Pythagorean triples. It comes out to 13. Okay, and now I can move to the outside, and I just set up the cosine ratio. So cosine of theta is adjacent over hypotenuse. My adjacent side is 12. My hypotenuse is 13, and our answer would be 12 over 13. So in our last lesson, when I asked you to do the inverse tangent of 4, we would create a triangle from that, okay? When it's something we can do, but not from our unit circle. So here would be another example. They are not the same function, so it's not just gonna undo each other, right? Cotangent of inverse sine. I can do the inverse sine of negative 1/3. That's in our domain, right? From negative 1 to 1. So this is a problem I can do. But if I go to my unit circle, my options for inverse sine are 1/2, square root of 2 over 2, square root of 3 over 2, 1, 0, negative 1. None of those are 1/3, right? So this is, again, where we are going to now move on to doing a triangle. Utilize, and in your triangle, always mark an angle so we know what we're basing our opposite and our adjacent off of. And it doesn't matter. I have a habit of drawing mine the same way every time. It doesn't really matter. I understand that this would not be in the correct quadrant for that always, but I just draw mine the same way, okay? So in this, it says negative 1 over 3. This would be my opposite, and this would be my hypotenuse. If I do my, right triangle, my SOHCAHTOA, that's what I was looking for, SOHCAHTOA. So my opposite side is 1, my hypotenuse is 3, and I need a negative in there. But do you remember our rule that the hypotenuse can never be negative? So that negative would have to be on your opposite. Okay. And actually, I'm going to flip this because we know that inverse cosine is coming from quadrant 4. So there's our opposite. There's our -1/3. Just to show you our last side is going to be positive as we move to the right here. Pythagorean theorem to find our missing side, as always. So be careful because this time it's going to be x squared plus -1 squared equals our hypotenuse squared. 9 minus 1 is 8. Ooh, we can break that down, can't we? And my missing side, it looks like is square root of 2, 2 square root of 2. Good so far? And then we move to the outside, cotangent. So I would be thinking tangent is opposite over adjacent, therefore cotangent is going to be adjacent over opposite. So looking at my picture here, my adjacent side is 2 square root of 2. My opposite is -1, which I could simplify to -2 square root of 2. Questions for me? Okay. The last type we're going to look at here is where they've got an X in them. Okay. Again, can I do this? Yes. Obviously, X is not coming from my unit circle, so it's not something I'm going to be able to go to my method and figure out. So again, we rely on right triangle. So anytime there is an X, now understand that means there's going to be an X in my answer as well. And we're going to have some unknowns going on in our picture here. So I draw my triangle, and this is a good conversation for us to have at this point. If it does not look like a fraction ever, it doesn't matter whether it's an X or not, I can make it look like a fraction by putting it over 1. And I want it to look like a fraction because tangent is opposite over adjacent. And now I have an opposite over an adjacent. So I mark my picture that way. Opposite side will be X and adjacent will be 1. Now, look at how our Pythagorean theorem ends up with a variable in it. So to find our missing side, which I'm going to call question mark for right now because a bunch of variables gets confusing in here. I'm trying to find the hypotenuse, right? So when I set up my Pythagorean theorem, we've got leg squared plus leg squared equals our hypotenuse squared, right? X squared is just X squared. 1 squared is just 1. And I still don't know what my hypotenuse is squared. But I want to know just plain question mark. And so we would end up square rooting this to get plain old question mark. Our hypotenuse equals, and that's just going to stay as is. Sometimes you're like, well, X squared is perfect and 1 is perfect. Can I square root both of those? Because of the plus between them, you can't simplify that any further. It stays the square root of X squared plus 1. So as I come back over here, I now know that this side right here, which was my question mark, is the square root of X squared plus 1. And now I use that theta to, again, identify my opposite adjacent hypotenuse and set up the outside function. Secant is the reciprocal of cosine, so it will end up being my hypotenuse over my adjacent. My hypotenuse is the square root of X squared plus 1. My adjacent is 1, which we wouldn't need to write. Questions? All right, let's try one more like that. They got really loud last hour, so we're going to shut this. All right. Setting up my triangle, it tells me to use the sine function, and the sine function is going to be the opposite over the hypotenuse. So I have a picture that looks like that so far. Pythagorean theorem again to find our missing side. This one very similar, but slightly different than the last one because our question mark, our unknown that we're trying to solve for, is one of the legs instead of the hypotenuse this time. So here's my Pythagorean theorem to find my unknown side. 1 squared is 1, and x squared is x squared. But this time I'm going to have to get question mark by itself by subtracting 1. And then square rooting. So our missing side that I'm calling question mark is the square root of x squared minus 1 this time. And once I have that picture set up, I can answer any of the trig functions they ask me about. So then I go see which one they're asking about, and they're asking about cosine. Cosine would be my adjacent over hypotenuse. So in this picture, adjacent is the square root of x squared minus 1, and the hypotenuse is x. Guys, that does not simplify at all. You just leave that as is. Questions? All right. Your assignment is on my math lab today.